This is a Toyota 2GR-FE engine. It's a 3.5 liter V6 with quad cam variable valve timing. Since 2005 or thereabouts, this engine has gone in a lot of Toyota and Lexus models like Camry, Avalon, RAV4, Sienna, Highlander, ES350, RX350, and there may be a few others in different markets that I'm not mentioning. This is an old engine that I keep around the shop for test fitting and other purposes. Today I'm going to show you many of the features of this engine. For those of you that are new to this engine, you may find this interesting. Let's start from the top. This is the upper intake and plenum. It's made out of a nylon composite. On this side, the intake has an electric motor that actuates the ACIS, acoustic control intake system. Basically, this is a variable runner flap that is inside the plenum, and it can set the runner length for the intake in two different positions. One for low end, mid-range, which is a long runner position, and the other position is for the top end, and that is the short runner position, and the changeover is at about 4,500 RPM. On this side, the engine has its electronic throttle control system, or drive-by-wire throttle, and this throttle uses a motor controlled by the ECU to set the throttle position. So that's a departure from earlier Toyota engines that used a cable throttle. The throttle body has two nipples for coolant circulation, and the warm coolant is intended to prevent icing of the throttle body that can occur at high humidity and low temperature conditions close to freezing. The plenum has several vacuum nipples. This small nipple connects to the vacuum actuated air box. This nipple is for the PCV positive crankcase ventilation system. This nipple is for the emission control, the evap system. And on the back of the plenum, there's another nipple for the brake booster. Let's take the plenum off and see what's underneath. Underneath the plenum is the lower intake. This has 6 runners that go into each of the intake ports. This intake is also where the injectors are mounted along both sides of the intake. You have 6 injectors. And let's pull this off and take a look. These are the bosses that surround the injector nozzles, and one common modification is to grind these bosses down flat to allow better airflow into the intake ports. Underneath the intake, we have the 2 NOx sensors. Here's the NOx sensor for bank 2, and here's the NOx sensor for bank 1. These are flat response donut style sensors, and these sensors have a sub harness that comes out underneath the water neck and connects to the main engine harness. Let's take a peek down one of the intake ports, and you can see the divider between the 2 valves and the backs of the 2 valves. And of course, this is a mess because this engine sat for a while. In the valley between the 2 banks, we have 2 solid metal pipes for coolant. These are the bypass tubes for the heater core. One of these tubes feeds right into the main water neck, and from there it goes to the heater core, and the one underneath is the return tube from the heater core. So these bypass the thermostat. Right here is the radiator return with the thermostat housing, and at the top of this housing is a port that you can ignore at your own peril. This is the bleed port for the coolant system, and it is at the highest point of the entire coolant system. While we're here, let me show you the lift points for the engine. This is one of the two lift points. It's just a boss with two M8 threaded holes in it that I've threaded two M8 bolts. And this is a door hinge from the hardware store, and I've just drilled two holes in it to match the threaded holes in the boss. This is the corresponding boss on the other side, on the opposite bank. Same deal, two M8 threaded holes, and again I've used another door hinge. So you can use snap links to attach to these door hinges, and with a chain connecting, you can easily lift up the engine in a balanced position. While we're on the subject of the coolant system, this is the water pump pulley. This, all the way to here, is the water pump. It has a characteristic shape that feeds both banks. And if you're interested, you can watch my video on how to replace the water pump with the engine in the car. The engine has two block drain ports, one on each side of the block. This is on the rear of the engine, underneath bank 1, and this is the drain facing to the front, underneath bank 2. The numbering of the cylinders is starting with the cylinder that is closest to the timing chain. This is cylinder 1, cylinder 2, cylinder 3, cylinder 4, cylinder 5, and cylinder 6. And the firing order is 1, 2, 3, 4, 5, 6. Also, I should mention that this is bank 1 facing to the rear, and this is bank 2 facing to the front, and they are known as the right bank and the left bank. And that orientation is taken looking from the back of the engine. This entire assembly is the tensioner assembly, and it bolts into the block, and the AC compressor actually bolts into the tensioner assembly. So if you ever need to replace the tensioner, you need to remove the AC compressor first. I'm going to show you one of the tricks for working with this tensioner. Notice the tensioner pivot has a hole right here, and it's just big enough to fit a hex key like that. So let me show you what you do with this. The tensioner pulley has a 14 millimeter hex bolt, and this is reverse thread. So using a wrench, you can turn the tensioner back to loosen the belt. Then you can insert the hex key through the hole and into a slot in the block, and this holds the tensioner back, which allows you to replace the belt without too much of a trouble. When the belt is back on, you just release the tension, pull out the hex key, and There, you're done. Of course is the crankshaft pulley, and this is an idler pulley. This idler pulley needs to come off whenever you go to access the thermostat inside the thermostat housing. All of the components and pulleys from this side are mounted right onto the timing cover, and the timing cover is this entire assembly that is basically has the complete outline of the block and the two heads. One note about this timing cover: at the bottom it is keyed into the upper oil pan. In order to remove the timing cover to get to the timing chain, you have to first remove the oil pan. This cavity is for the main tensioner for the timing chain. Normally it has a flat cover over it, but this is where the chain tensioner sits. These holes you see right here are the holes for the mounting system. And for the RAV4, the weight of the engine is actually supported by the mounting system on this side. For other engines like the Camry, Sienna, Highlander, what you have on this side is a torque strut to prevent any rotation of the engine. Let's turn our attention to the valve covers. This is a quad VVTi engine, so it has variable valve timing on both the intake and exhaust on both banks. And in order to control this, each bank has two valve timing solenoids and two camshaft position sensors. These are the sensors and solenoids on bank 2. On bank 1 you have a sensor right here, two solenoids, and I've scavenged the camshaft sensor of the exhaust. This gizmo over here on top of the valve cover is a flux capacitor. No, excuse me, it's a radio frequency interference filter. And people assume because of the name that this is to allow proper radio reception. Nothing could be further from the truth. This is to filter out the electrical pulses, electromagnetic pulses that could interfere with the ECU, not the radio. This right here is the VIN plate. It has the VIN, or vehicle identification number, of the vehicle that this engine came out of. And this is present on all US engines. It may not be present on engines in other markets. On this flange, there is an engraving of a serial number. This is the engine's serial number. It does not identify the vehicle in any way, but it does identify the manufacturing plant and the date of manufacture of the engine. Let's pull off this valve cover and see what's underneath. Now, if you want to see how this is done correctly in the car on a real engine, you would watch my video on changing the valve cover gasket. As I said, this engine has had some weathering. The gears for the cams are missing. This is the intake cam. This is the exhaust cam. Yes, they are all rusty. Now, these are the caps that hold the cams down onto this tray. And if the timing cover were not here, we would be able to just remove this entire tray with the cams with it. And you can see it has freedom of motion, but it is keyed in to the timing cover on this side, so it's not possible to remove it. If the timing cover were off, you would be able to remove it. Some of the points to note on these cam caps: these locations right here are oiling holes. This one here, these here, and these have O-rings that you must take care to replace or just make sure they are present whenever you disassemble or reassemble the valve cover. I'm going to go ahead and remove all of these caps and remove the cams and show you the valve rocker mechanism. So as you can see, I have already removed the rockers from 2 of the cylinders, and I've left the rockers on both the exhaust side and the intake side for just 1 cylinder. Let's take a closer look at these. So here we are looking close in at the rockers and valves for cylinder number 2. The exhaust cam sits right on top of these 2 exhaust rockers with the exhaust cam lobes acting onto the rockers. Now, one thing we note is, although we have rockers, there is no rocker shaft. The first time I saw this, it kind of floored me, because you always expect rockers with a rocker shaft, but these rockers are completely free floating. They just sit in position with nothing to keep them in place. And on one side of the rocker you have the valve stem, and the valve stem has on it a little cap like this that sits right on the top of the valve stem. And on the other side you have the lash adjuster, which is sometimes called the lifter. This is a hydraulic lash adjuster. If I were strong enough, I would be able to squeeze this, and actually I did deflect it just a tiny little bit right there. But this sits in a little cavity and maintains the correct lash for the valves as the camshaft rotates. And as I've said, there is nothing holding the rocker in place. This rocker has a roller. Okay, it has a roller, so the camshaft lobe acts directly onto this roller, and it pushes the roller down, which pushes the valve open. Now let's look at the location of the head bolts. You have one here, one here, one right under this cap, 2 under the cap. You have 2 more under this cap, and finally there are 2 more on the end under this cap. And to remove these head bolts, you do have to get the tray out of the way, which means that you have to remove the timing cover. So I'm going to go ahead and do that. Before I remove the timing cover, I'm going to show you something to do with the oil pump. If you look closely, this is the oil pump housing right here, and the crankshaft has a square cam that turns the oil pump, and when you're removing or replacing the timing cover, you have to watch to get these cams into position. So the timing cover comes right off. These right here are the gears for the oil pump. This is the Reluctor Wheel. Now we can move on to remove the camshaft tray. So now that we've removed the timing cover, this tray can come right off, and if the camshafts were on it, they would come off with it. And now we have unrestricted access to all of the head bolt locations. Let's have a little bit closer look at these head bolts. These head bolts have a 12-point head. Now some people use a triple square on this, but these are not actually a triple square, it's a double hexagon, which is different. And the difference is on a triple square, the points all have a 90-degree angle, and on the double hexagon, you have a 120-degree angle on every point. And the tool that you use with these is a 10mm tool with 12 points, and it provides a very secure fit into the head of the bolt. Okay, and the reason I mention this is you can get away with using a triple square most of the time, but at some point you won't get away with it, and then you'll be in a world of hurt because you'll have ruined a head bolt, and you'll have to drill it out. Another thing I want to tell you about these head bolts is, first of all, each one of them has a little washer that goes on it, so keep track of these washers. But the real thing I want to tell you is these bolts are reusable. They are reusable. The factory service manual has a spec that you can use to measure the threads on each bolt, and if they are within spec, then you can reuse them. I'm going to say something else about using these bolts versus using head studs on the 2GR-FE. The ARP head studs must be retorqued after you heat cycle the engine. The only way you can heat cycle the engine is put it in the car, and the only way you can retorque the ARP head studs is to take the engine out of the car. So for that reason, I'm sticking with head bolts on all my builds. You just set them and forget them. One more thing to do before we can take this head off is to take this water neck off. And this has an O-ring right here, which kind of holds it in place, but it pops right off. Now with the water neck off, the heads will come right off, and you can see my temporary head gasket there. It's multi-layer cardstock. The next step of what we're going to do is to remove some of the valve springs in some of the valves. And that's so we can take a close look at the valve seats. So the tool I'm going to use for this is this Toyotool, and it works by just pressing up against the valve retainer. Okay, and it has a magnet on the inside that will catch the keeper. So before doing this, I've set a rag under the head, under the valves, and this is just to keep the valves from dropping out. Not that it really matters, but it also provides resistance. and just position the tool over the retainer, press down. So these keepers are now off, and the retainer and keeper have both come off, and the spring can come off. And this valve is just held down against the rag. So let's remove the other three on this cylinder. Okay, so that's it for removing the valves from one cylinder. You just flip it over now, and these valves should just pop right out. We go to exhaust valves, to intake valves. The intake valves are quite a bit larger. So as you can see, these valve seats are right up against the circle of the cylinder, and to get bigger valves in here, bigger valve seats, there's just really not much option to do that. Let's shine a little bit of light on this. Well, maybe there's a way. So maybe there's a way to get a little bit bigger valve seat in here and fit a little bit bigger valve. And honestly, it's awfully tight. It's very, very tight. And let's check for the exhaust valve. The exhaust valve is even tighter. There's just no room there on the exhaust side, unless if you were to bore the cylinder from the stock 93 millimeter to 97, so adding 2 millimeters on each side. Okay, and then at that point you could possibly enlarge the valve seats and fit bigger valves. So I'm going to take this to a qualified machine shop and see what they think. While we're here, let's take a little bit closer look at what we might be able to do with these ports. I mean, we would look for like any casting marks or anything on the inside that could be done to improve the airflow, but to be honest, I'm not really seeing much on this port. Maybe if I were to clean it up better, any surface roughnesses or irregularities would stand out better. But in the shape it's in right now, it's hard to see anything at all. One more thing let's look at how we would remove and replace the valve stem seals with the valve supported. Take a tool like this, grip the seal, and just you pull it out. So this is our valve stem seal. It goes right around the valve stem, obviously. Then to put one back in, you just reset it around the valve stem. Actually, easier. Just reset it, push it down, and you want to grip it and push it in pretty hard. So there, it's set in place. Finally, let's have a look at how we would get a valve spring back in place. And I'm going to do this from the side so you can see this a little bit better. First, I slip the spring on top of the valve. I support the valve from underneath so it doesn't go anywhere. We take the retainer with the keepers set very lightly into the retainer. We line them up with the valve stem. We take our valve tool with the installation end, match the ball into the keepers, line it up, give it a good hard shove. And that's almost there, but not quite. Let's try again. And there we got it. That's the proper way to install it. That's it for this video. I'm going to leave the bottom end of the engine for another video. We'll look at the crankshaft and the oil pump and all the rest of that stuff. But for today, you've seen some of the main features of the engine. You've seen how to take it apart, and you've seen the camshafts and the heads. Hope you enjoyed it, and thanks for watching.